Hi everyone, welcome to my talk, XSS, CSRF, CSP, JWT, WTF, IDK, shrug emoji. You have to pronounce that, that's important. But to make it a bit easier, over the next 30 minutes I would like to give you an introduction to web security, because I firmly believe that security is something that not security researchers should only care about, but really every developer should have security in mind when they're developing apps. And I will definitely not make you security experts in the next 30 minutes. I don't consider myself a security expert. But I think all of the things I'm going to talk about are things that we should constantly keep in mind when we're building apps and we're talking about development. And hopefully by the end of the talk, all of these abbreviations are going to make a bit more sense if you're still confused about them. Quick introduction to myself. My name is Dominik. I work as a developer evangelist for Twilio in Berlin. We do sort of any kind of communication API that you can imagine by now. So we start with SMS and voice, but we also do things like video and chat. But there's one more thing that you should know about me, and this is where this talk has its first weird twist. And this is where I can get rid of my jacket. And get really weird. So I'm part of a group. So I'm part of a group of onesie-loving JavaScript developers. We call it onesie.js. This is us at a conference in fall last year in Germany. A few of us are here. I'm not sure if Stefan is right now here. If he's not, you'll see him later on stage. But, you know, like these days, there's like a bunch of social networks for pretty much everything. There's Facebook to rule them all, but there's like pretty much for every interest one. Unfortunately, none for JavaScript-loving developers. So being a developer, I kind of did what every developer does when they're frustrated with something not existing. I built my own because you can never have enough social networks. So I built Onesie Live, the fluffiest social network that exists. And as a developer, I obviously made sure that this is secure in every way possible. So I thought of everything that there is. I used HTTPS, and thanks to Let's Encrypt, I don't have to pay a dime. So there's really no excuse that your website is running only on HTTP. And it uses HTST, so that's the annoying thing that doesn't let you go to Google if you're on a public Wi-Fi and there's a captive portal trying to redirect you. But basically what that does is it ensures that there's no downgrade in the security of the websites you're visiting throughout the session. And I make sure that there's no mixed content, so there's no HTTP content in my HTTPS website. I sanitize my inputs, so this is a social network. Obviously, you want to post cat pictures. And I do that via Markdown, but the Markdown is sanitized before it's placed into the page. And there's no room for SQL injections because I don't really use a real database, so there can't be any database injections. It's really the best tip to do this. But be aware there are no SQL injections, even though we mostly talk about SQL injections, there are no SQL injections. But I really just use a plain storage. Turns out, though, that developing secure web applications isn't as easy as I thought. So I asked my friend Bob Allison to kind of like take a stab at this, and he found a bunch of vulnerabilities that I wanted to share with you today. All right, with that, let's start demoing things. If I click here. So this is the website, and I'm going to open the DevTools on the side just to take a look at network. So I'm going to log in with my super secure password here. And what we see is a bunch of requests, but the login request basically just does a post request, and it gets back, and like the important one is this auth token cookie over here. And if we look at it, so I got a kind of helper tool to help me with the cookies here. So this is what is called a JWT or JWT or JSON Web Token. And they have a very particular format. So if we go here, we can inspect this. And we see it has three different parts. They're colored here red, purple, and blue. But basically, it's the first one is a header that defines certain things like the algorithm that the signature was generated with, which is the third part. And then we have a payload in the middle that basically contains data, and you can put sort of any data you want into that. So in my case, I have the role of a user and then two standardized fields, which are subject and issued at, which are specifying a timestamp when the token was generated and the username of the user this token is for. If we scroll down, we can also see that this has an invalid signature. That's purely because I'm trying to verify it against a secret called secret, and I was smart enough to not use secret as my secret to generate these. However, there is this thing with this algorithm that if you look at the spec, there are multiple algorithms that are supported, and one that should be mandatory to be implemented is called none. And if you look back here, we see that there's a third part missing, because if you have no algorithm to generate the signature, you have no signature. Now that by itself is debatable. There are use cases for it, but the fun starts when I start modifying this, and I take this and throw it back into my application. So I'm going to update the cookie and set this in, and let's see if you can sort of like spot the difference when I reload the page. But we're now an admin. And so basically what happens here is that I kind of treat the role attribute in this thing as a source of truth, because it's signed and therefore like nobody can tamper with it, right? But unfortunately that's possible, at least in the situation where I'm using it now. So let's talk about how we can actually fix this. So the first thing we should be doing is we should use cookies. If we use them in this, like in this case, we should use them as HTTP only cookies. And what I mean with that is that we should have cookies that are not accessible via JavaScript. So if you set this flag, you're able to make sure that this is not accessible via JavaScript, because there's no reason for it. It should just be transferred during requests, and that's it. The other thing is it should be signed, meaning we sign it with some secret so that nobody else can tamper with it, and it's useful to mark it as secure, so it's only transferred over secure connections. The other thing that you want to do is you want to use a safe JWT implementation. So the one that I was using is actually the same library here. I was just using an old version, and this old version has two things that the new one, two vulnerabilities that the new one doesn't have. And those are things you want to look out for. The one is your library should make sure that if it's passed in a secret, it should not allow the algorithm none to compare the signature, because like you're obviously expecting a signature, so that should just not be allowed. The other thing is it should allow you to whitelist algorithms, because there are ways to kind of even play out this like secret signature part if you're not whitelisting algorithms. So in my case, I expect HS256, and therefore I'm only going to allow that one, and that then actually secures my token, because if I'm using a different algorithm, this will break. So the bottom line here is don't be Equifax. Basically, stay up to date. If you don't know that reference, they were recently hacked. It was a major hack because someone didn't update one of their softwares that actually had a known security vulnerability. So you should always really stay up to date with your this is really annoying. That's better. You want to stay up to date with your dependencies. All right, this is a social network. So what do we do at social networks? We post things. I don't have a cat picture prepared, admittedly, but I said that this is Markdown, so we can do Markdown things like hello, and then I don't know, do like JSHeroes. So we post this, that all works. And what happens under the hood, if we go back to the network tab and just do that again, is we see that this is just an HTTP post request with form data. And in this case, it's just the message as Markdown. And that's it. And we use the auth token then again to authenticate the user that we can really post on their behalf. Now, the fun thing here is that attackers can use the same thing to perform so-called cross-site request forgery. So if we go to this page, which is hosted on a completely different domain, in this case glitch, and we go to this valid attack, we'll see that it says you got pwned. But what does that mean? Well, if we go back here and we refresh the page, we see that the other website was actually able to post on my behalf. And that is because the browser acts in a way that it sees, oh yeah, I have some cookies for that website, and just sends them along without actually asking like whether that makes sense or not. And therefore, basically a website can post on the behalf of a user just because they're authenticated. So this is actually the entire code of the application. There's no magic here. All we have is a form that posts to the URL that I'm on, and it has an input field. We could even hide this with CSS so the user would not notice this. And then when the page is loaded, we just submit the form. That's all we do. Like there's no like hacking around, like reading cookies or something. The browser does it for us, so we don't need to do things here. And apparently my slides were hacked in the process as well, so that didn't work out fully. Let's go back. Cool. Oh, so two things that happened. The first one is, let's talk about how my slides actually were hacked. So when I went to the website, this thing is a Targetblank link. Nothing magic. But when you open a Targetblank link, by default, the new page has access to window.opener, which is referring to the opening window, and that one has a property called location. And what can you do with a location? You can read it, but you can also write it. So in this case, the attacker's page basically just rewrote the URL, in this case to a harmless page on my slides, but the thing is that the attacker might as well just redirect you to, for example, a phishing page that looks exactly like your page. So imagine in the case of Facebook, if they would use Targetblank links and they don't use them just in like a blank version, if you post a link, then basically the link that you're controlling could then rewrite the link of Facebook, and the users would not notice. They would think they were still in Facebook. You could like prompt them for their username again and their password again, and nobody would like bat an eye, except if they really see it like in the URL bar. So this is a dangerous thing. It's really easy to protect yourself against it though, by using the rel attribute and using no opener, which basically then blocks the access to this window.opener property. But then also no refer, just for some browsers that are not familiar with the no opener attribute here. There are also some scripts that allow you to kind of protect yourself against this attack, but there are some ways to circumvent those as well. So this is sort of the best way to do that. And then how can we protect ourselves against cross-site request forgery or CSRF attacks? This is an interesting concept, and it's fairly easy as well, because what we do is when we get the page that we want to later, for example, do the form submit on, we will transfer a cookie called CSRF that we give some random value, and then we also put that into the template at some place. And the reason why we do that is that when we submit the request later, we will see that we will send this not only as the cookie, we will also send the same value either as a form body or as a query parameter or as an HTTP header. So for example, libraries like Angular have actually support that you can just set this CSRF token inside their like HTTP protocol, and it just like sends it with it. Then basically we match these up, and the reason why this works as a protection is that there's no way that the attacker can read the cookie. It can only rely on the browser sending it, and therefore there's no way it can, the attacker can send it twice, once either in the request body or something similar and as a cookie. All right, let's talk about Little Bobby Table's younger brother, the cross-site scripting attack. If you're not familiar with Little Bobby Tables, it originates from this XKCD comic where basically a family of hackers named their kid like a SQL injection, and the director of the school is pretty mad because they dropped all the student records because they weren't sanitizing their input. And this is source code of a famous XSS attack, and I'm wondering if anyone knows what this one is. So far, I haven't found anyone who knew this. All right, so this is the Myspace worm, or Sammy worm, or JSHeroes worm from 2005. And basically what this did is, it's called Sammy worm because Sammy developed it, and it would basically, he posted it on his page, and it would like spread to all of his friends, and then his friends would spread it, like everyone who would go on their profile kind of like friended Sammy and then also posted on theirs, so it spread. That's also how they caught him, because he had suddenly millions of friends overnight. which is a bit suspicious. But the nice thing about this is that we can learn that XSS protection isn't really easy, because MySpace had XSS protection, but Sammy found different ways to circumvent that. And he blogged about that, so we can talk about those. So two kind of tricks that he used that I thought were cool were these two. Like, on the one hand, MySpace avoided the way of using inline script tags, but they allowed CSS. And in CSS, he could set a background URL, and then as a background URL, he could set the JavaScript protocol. Unfortunately, he couldn't use quotes in there, but he circumvented that by actually setting an HTML attribute with the entire code he wanted to execute, and he could use eval, so he just evaled the whole thing. And then the other thing is they blacklisted some words. So like they blacklisted inner HTML, for example, and on-ready state change, which is basically the built-in AJAX way to do AJAX if you don't use jQuery or something, or fetch these days. And they blacklisted these words, but what if you just put them into strings, split them, reconcatenate them, and then eval them? Then no regular expression is going to grab that anymore. So that kind of helped Sammy and many other ones, if you want to learn more, like check out that blog post, to circumvent the XSS protection. Now, both of these things use eval, so the solution might be to not allow eval, but unfortunately that's not easy either, because JavaScript is really good in writing the same thing in a million ways. So all of these do eval. The first one is probably the most obvious one. The bottom one is the least obvious one. And you can kind of combine all of these, right? Like there are a bunch of other ways as well. There's a talk from Martin Kleppe from JSConf Iceland where he showed how to write JavaScript in like different languages, like not programming languages, but just different character sets. You know, like how to write it in Hebrew or in like different fictional languages, as long as you have like the character set support. And so, you know, blocking XSS isn't trivial. And in fact, I told you I'm sanitizing the input, but on the other hand, I actually have an XSS vulnerability in here. So I use a library called marked to update the to generate the HTML. It's a fairly popular library. So does anyone use marked? All right, a few people. I hope you don't get a heart attack now. So let's start with. Obviously, I'm sanitizing, so this doesn't work. So if we see this, it's sanitized. Now we can use a similar trick to what Sammy did and try to create a link here and use the JavaScript protocol. So we're just going to alert here, could really do anything. And I'm going to copy this, and it's escaping that as well, because that's an obvious one, so that's blocked. Now, I said encoding is fun, right? So this is the encoding of a closing parenthesis. And if we do the same thing here for the colon and do hashtag 58, and we post this, we already see there's a difference, because suddenly there's nothing here. That's because the library is still smart enough to figure out that hashtag ampersand hash 58 semicolon is really just a colon. Now, the fun part is if I change this to this, and shout out to Guy from Sneak who showed me this. If I post this, this suddenly works. And the reason why this works, if we click on it, we will see there's an alert statement here. The reason why this works is that the browser is trying to be nice by basically saying, hey, I see ampersand hash 58. I don't see a semicolon, but I believe you wanted to type that, so I'll just insert it for you. So this is still a colon, and then afterwards is JavaScript. That's why I wrote this instead of like anything else, because that's valid JavaScript. And therefore this works. Now this actually is fixed in the latest version of Marked. It took a while, but it's fixed now. Unfortunately, there's still a vulnerability around data URIs in there, at least last time I checked. So just be aware when you're using this. But the data URI one is a bit harder to demonstrate, so I opted to this one. So bottom line here is encoding can be dangerous, and just be aware of that. Like there are a million ways to write the same thing. And also don't trust CSS, because CSS can be dangerous as well. There are different things like the key logging thing, and Jake Archibald published a month ago or something a blog post about why you shouldn't trust CSS. That is great to check out, because there are a lot of ways that you can kind of compromise security on that as well. Let's talk about JSON-P. I think we don't talk about that often anymore, but I think it's still fairly widespread. So JSON-P, if you're not familiar with it, is a way for you to circumvent same origin policy to asynchronously grab data. Meaning if you're trying to grab data from another website with AJAX, this will be blocked unless certain headers are set. For a long time, this kind of way around that, a common way around that was to use JSON-P. So the idea here is we declare a global function, and then we dynamically inject a script node. And what the script URL would do is it would grab the callback parameter, or it could have different names, take that name and wrap the data into a function call for that. So this sort of acts like a callback then. Problem though is if you implement this poorly and you have an XSS vulnerability, now we're getting to fun things. So how many of you know service workers? Ooh. So let's see if you have an idea what I'm doing here. So this code is a bit longer, so I prepared it. So I have a bunch of code here, and you can already see I say service worker here. So if I post this and I click this link, and we refresh this website, I'm hacked, and the reason is, if you're not familiar with service workers are network proxies that you can install, and they kind of intercept network requests, and you can override them and stuff. It's the idea to build offline available apps and things like that, and kind of control caching. And because it's such a powerful tool, it's scoped to only run on your own domain. So you can't install a service worker from a different domain. If you have a vulnerable JSON-P implementation, though, you can pretty much put any content as the callback and generate your own scripts hosted on that domain. So that's what I did here. So you can see it's just a very long callback name that ends at one point, if we prettify this, has at one point a // so turning the actual data into a comment. And then everything else, we can just write whatever we want. In this case, we're just overriding the request here. And that works. We could, though, do a more subtle attack and secretly kind of inject script tags, for example, that modify or keylog or do things like that. And this is something that's hard to detect for a user, right? If you do this secretly and your team doesn't catch it, a person probably is not going to catch it, because how often did you go to your service workers and you actually clicked on this drop down that says service workers from other domains, because there are a lot installed, and I'm fairly certain you didn't read the source code of those. So it's certainly a dangerous feature. So if we unregister this, we're again on the good side here, and we can load the page. Let me go back to my slides. Go on, there we go. So there, I showed you a bunch of vulnerabilities, and there's luckily a new hero in town that helps you with a bunch of these. Even though you should fix them the way I showed you, there's the content security policy, or CSP, that allows you to kind of fix a lot of these without actively fixing them. And I have a demo for that as well. So this is the entire same page. It's the same data set and everything. The only thing is I'm applying a CSP to it. So the difference is we don't see any images loaded here that I had previously. If we go to this one, you can see images here. And there we go. And then the other thing is that if we click on any of these links, it doesn't do anything. And the reason, if we open the DevTools again, is that we get a bunch of red errors here, all kind of stating the thing that you're violating the content security policy. And then some requests trying to report this. So the way CSP works is it's just an HTTP header, or you can use a meta tag in HTML as well if you don't have control over the HTTP headers. And here you write rules that the browser should play by with respect to resources for your page. So you can set a default source. In this case, I use self, which is basically anything that is hosted on my own domain. But then I also say that scripts, for example, should really only be the ones that have this certain nonce on it. And that one changes on every request, so you can't hard code that. And that also means that's why the clicks didn't work, because like it recognizes that that's inline JavaScript, and that's not permitted by my rules, so therefore it doesn't work. I'm avoiding any objects because I'm not planning to put Flash in there. I only allow image sources that are on my own domain or api.adorable.io, which are used for the icons, but that's why the Twitter images are not loading. And then I use font sources like Google Fonts. I block all mixed content just to be safe. And then I use a report URI that basically is going to receive a post request for every violated request. And the thing is that there's also a report-only mode, which allows you to say, hey, don't actually block the content, but if anything violates it, just send me a report. This is useful when you're like initially starting off with this and you're testing it and you're like slowly, gradually moving into it, just so you're not like completely blocking your users off because you just tried this. The thing is, though, that CSP shouldn't be your security strategy. You should be aware of all these vulnerabilities, and you should make sure to like not allow XSS. Should keep up to date with your dependencies, and really just use it as a safety net, so that if you miss something or if there's a vulnerability in one of your dependencies that you didn't catch, that this kind of blocks you, helps you. Because the thing with CSP is it's really hard to write a really secure CSP. There are papers by Google of like trying to figure out like which ones are actually useful CSPs. A lot of the websites that use CSP didn't have a actually strong or useful one. So it's tough to work on this. Other things you want to look out for, you should avoid clickjacking, meaning you shouldn't allow allow others to iframe your page so that they could kind of like overlay another page on it and trick your users into clicking things that they don't want to. And you can do that by setting an HTTP header. If you're using Express or something similar, there are libraries like Helmet that allow you to set certain security headers that are just generic headers that everyone should have set, including the Xframe options one. Don't show the versions of front-end libraries or like your server to the user. While that's useful for you for debugging, that's useful for attackers to figure out which vulnerabilities they should check out first. So if you're using something like unpackage or something, like that's great for debugging and for development and stuff, but you don't want to display that you're using like version 16 of React, because then they know, all right, those are the vulnerabilities I want to test for. And check for types for your input. So if you're expecting a query parameter to be a string, verify that that's a string, because there are libraries that do parsing for you automatically, especially for query parameters and post parameters and stuff like that. And suddenly a string turns into an object and you have a NoSQL injection. So always check for the inputs that they're what you're expecting them to be. Other things, security is hard, so consider a security audit on your code base. If you've never done one, do at least one. If you had major changes since then, do another one. And if you don't have a security expert on site, hire a consultant to do it, because it's really helpful. Because if you're actually being breached later, that's more expensive than hiring a security expert to do like one audit. Stay up to date with the versions of the dependencies you're using. Greenkeeper is a useful tool for that. And use tools to detect security vulnerabilities in your dependencies. So NSP or Sneak work great on that. To wrap this up, use signed HTTP only cookies, unless you really need to access them in JavaScript, but then they should probably not be like security related content. Be skeptical of JOTs. Don't treat them necessarily as a single source of truth, and make sure that you have a library that is actually bulletproof to use them. Use the rel no opener no referrer tag on your links. Use CSRF tokens whenever you're allowing users to do something, like if you do something on their behalf. Blocking XSS is really not trivial because you should be aware of encoding. Be careful of JSON-P. Like, you shouldn't allow anything in the callback name that isn't a word character, like especially not, like even not digits and stuff. Just only word characters. Use CSP as a safety net, and most importantly, stay up to date with your dependencies, because if they fix vulnerabilities and you don't update, like, you still have the vulnerability. I'll post the slides in there, and I'm going to tweet them out, so if you want to check out the resources. All the kind of vulnerabilities are in this repository, including additional ones and documentation and additional links to it. And with that, thank you everyone for your attention. I'll be around for the rest of the day. So.